Okay, so we went through this one in class, and this one says write a program to print the sum of the first 10 counting numbers. If we come down here, the counting numbers we know up to 10 are 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Okay, I think 10 is part. Yeah, so these are the first 10 counting numbers. All right, now to get a program to write their sum, we need to get the program to first bring those numbers. How will the program bring those numbers? In the previous video, we have uh, what we saw was we are supposed to at least think of how to generate the numbers. So we think of the first one, assigning the first one to a variable called x, and then we come down. When we come down, what we do now is to look at the keywords inside the question. We are supposed to find the sum. So if we need the sum, where will we be getting those numbers? We will get the numbers in a loop, because since we know the first number, to get the rest of the numbers, we will have to put this number in a loop, increasing it continuously, so that we will get the counterpart. By counterpart, I mean the rest of the numbers. So if we are generating the rest of the numbers in the loop, then it means that the sum, we need a variable. So we can't use the same number to be storing the variable. Take note, you don't buy the variables. They are free. So you can create a number of variables you need, provided they are relevant to the problem given you. So in this case, we need a variable to be storing the sum. But in mathematics, we have something called identity. And an identity, what an identity does is the moment you have a number, every operator has an identity. So if I have 5 plus 0, it gives me 5. So in mathematics, the identity for addition is any item or any number that when we operate with another number, we get that particular number. So in this case, anytime we operate 0 with any other number, we get that any other number, right? So we have 5 plus 0, we can have 2 plus 0. It gives us the same 2 that we used. So basically, these identities do not change the value of the number. In multiplication, it is 1, and then 1 produces the same effect. That is why when we are initializing, we initialize with the identity of the operation. In this case, the operation is sum, and sum has to do with addition. That is why we initialize with the identity of addition, which is 0, right? So sum equals 0. Now we are going to enter the while loop. Entering the while loop, we need to write the while loop, and now we need a control variable, something that will cause the loop to stop. Because we would end at 10, that is the only time that the loop is going to stop after we are done with the execution of 10. We need this same x to be less than or equal to 10. That is the only time we will run. So we'll run the loop even when x is 10. So in this case, end while will be the end of the loop. Now we are here. What we need to be doing is, this loop does not end. It runs forever, because there is nothing that causes the value of x to change. So we will not have access to 2, we will not have access to 3, we will not have access to 4, we will not have access to 5, and then the rest. So we need something to change the value of x anytime the loop runs. And so to change it, we now say x. So this one will change the value of the control variable. So at least now we are sure that the loop can run 10 times. So it will run for the first time when x is 1, and then it will run again, but by the time it runs again, x has been increased. We've done this already. X has been increased, and when x has been increased, it runs again, it runs again, it runs again until x is 10. When x is 10, it still satisfies the condition. It will enter. When x is 11 now, the loop will not run anymore. So we enter the loop. We try to enter the loop with 11. Is 11 less than or equal to 10? It is false, so we will not run this at all. Now, while the loop is running, well, we are going to enter this loop when x is 1. So over here, x is 1, so they will compare it to be true for the first time. And then we will enter the loop. When we enter, what we need to do is to sum or increase the value of sum by the value of x that was able to enter the loop. And over here, for this time, x entered with a value of 1. So we are saying that the value of sum, which was 0 right now, sum which is 0, should be added to the x that entered. So now for the first time, sum is 1. When the loop goes and then x is now 2 over here, they are going to say the value of sum plus the value of x that has come, and the new value of x that came is now 2. And then they will go and come again, and then they will add 3 until they now get to the final end. This is the same for finding the product. So the moment we are going to find the product of the first 10 counting numbers, x will still be the first of this series of numbers, and then sum is not going to be sum again, it's going to be products. You can change the name of product, but the variable you use should make sense. So if you are not writing it as product over here long like this and you want to write it this way, it should make sense. All right, so product, but product is the result after multiplication, and the identity for multiplication is 1, not 0. So you need to change this to 1. The moment you change this to 1, all this sum something should be changed to products. These are variable names I'm using. You can use your own. Over here, what we want to do is to multiply the value of x by the value of product that we already have. So I need to change this to multiplication. I won't change this to multiplication because I don't want to be multiplying the value of x anytime it changes. What I want to do is to increase the value of x so that I'll get the next number. What I want to do is to increase the value of this x so that I get the next number. So I don't need to be multiplying over here. What I need to be doing is to be finding the product. So the first time product is 1, we get 1 as a number after it has entered the while loop. We will multiply 1 by 1, assign it to product. Product is now 1. Now x is increased, x is now 2. They will use it to check. If it checks is 2 less than or equal to 10, they will say yes, 2 is less than or equal to 10. If 2 is less than or equal to 10, then multiply the value of product that we had after the just ended iteration, which was 1. Multiply 2 by 1 and assign it to product. Product is now 2 because 2 times 1 is 2. They'll give it to product now. And then now they come here, they increase x, x is 3. They check, is x less than or equal to 10? Yes, it's true. So 3 times the 2 of product previously gives us 6. Assign 6 to product. That is what happens. And at the end, when x now becomes 11 after this increment, this loop will stop running. When this loop stops running, we will now be able to print the value of products at the end of the whole program. So this is basically how to get the product. We needed to generate these numbers, and the only way we can generate these numbers after knowing the first of the numbers is by getting a loop. And when will the loop end? The loop will end the moment we get a first 10. And the first 10, because we are using this first number, which is the variable that we want to use as our control variable, we want to end when it is 10. Okay, when it is 10, that's how come we have this. So basically, this is it. If you have any questions, you can ask it in class.